Hi everyone. Today, I thought we're gonna do some reverse engineering into some interesting malware that I haven't analyzed for some time now. I did take a look quickly yesterday, but it's fairly complicated, so I think it's gonna take a few videos for this. So from a starter, so recently I captured this screenshot of a victim, right, from an info stealer. And what popped out the most to me is, this. So this is a executable file. So the person was watching, and I would assume downloading this file that in this YouTube, right? And the user was shown how to running a malware. And I think this is the start of the infection. That's how he compromised his machine and got the desktop stolen. From here, so what I did is I searched from Hama001. So let's do this real quick. Let's close this out. Let's go to YouTube.
Hi, I'm going to...
Okay, so it's gonna be Hama 001. Is this the one? Is it Hama 001 design? So this is the file that they was watching, right? Adobe Multimedia. So this is the typical malware that's been spreading on YouTube for a very long time. So cyber criminal, basically they taken over an account or creating a channel, then they're creating this type of fake video instruction on how to run a malware, right? How to running a crack software or game cheat or something like that. And they're providing instruction to download the payload. So this payload, instead of Adobe Media Encoder, is actually a malware within it, but they encode it as if it's a real thing. Okay, so let's take a look. So we go into the graph. Notice, so they have two layer of reader of download links. One is the graph.org, and the second one is Cutley, right, the URL encoder. So which redirect to Proton. So as mentioned, always use proxy, and I usually use a no script in my browser so I can control what's being run in here. So let's do this. Let's download it. It's 108 megs, so it's fairly large sample. The reason why they do this is to make it as if it's real cracked software or legitimate software. So I'm gonna put it in my 19 folder in here. Okay. This is obviously a raw file, so it's encrypted with the archive path. The reason why most of this malware on YouTube adding the password in here is to creating the automation like detection to block them from extracting out and identify the malware within it. So that's why you're seeing passwords over the place, and they use different type of name for it, archive pass or just password or just P or something like that, just to forcing the automation like scraper to not detecting it. So now extract this out. Subportal. Yeah, so installer x84. So that seems very typical, right? Software installation packet here with the setup, ICU, DT, and data, etc. So let's do files, files is executable, so let's do strings setup. This is interesting. Anything stand out? Oop. So they're using extracts. So the software is a set of file. So they're using it to extract out the payload, right? So it's an installation packet. Okay. Let's open up virtual machine real quick. Here's a virtual machine. We're gonna run it and just see what type of payload it is. We disable the network just in case, and drop in the files in here. For this type setup, usually running resource, using the resource hacker to see what type of content in there. So from here, as you've seen, this is a IE Express extraction tools, and the payload is in here. Right, so got the AutoIt, interesting. So this is a malware that running AutoIt script. Okay. So one way to extract this out is to see if we can do it with the 7-zip. Where's my too many window? My apologies. X setup, O setup. So for the 7-zip, they have a lot of different type of packet management of file type that they able to handle, and you usually able to decrypt it or extract it out very easily. But in this case, it's failing, so I'm just not gonna take a look too much into it. So one way for the IE Express file. What we can do is we can use the command to extract it out. So we do the so run setup /t users root j desktop /c. So important to use the /c to make sure it's don't run it, just extract it out. So as you've seen here, they extract out 2 files. The file in here, so we have 2 samples, right? The AutoIt and charge.a3x. .a3x is a script that is encrypted. So you will need to decrypt the file. So one of the software that you can use is the AutoIt decryptor. So let me see. So I'm gonna put it in here. this is a AutoIt Extractor great script application to decrypt the encrypted file. So all you need to do is just drag it. You can download this on GitHub. So just search for it, AutoIt Extractor. So let it run for a little bit. It's gonna index the code. Then you're gonna get it, the sample out. Okay, save. Let's do the charge. AU3. Okay, then you would move. So I'm just gonna save everything back into my machine. Dragon is having problem. So usually you can run this, get this script as well, but for this case I usually might as well do it. It's my dragging my virtual machine is not working great for some reason. Yep, see, okay, pop up. Okay, anyway, let's take a look. So we want the 3. Okay. I'm not sure if they have auto. No. So I'm just gonna use like Java or something. Let's see if it just encoded. Okay. So notice they using obfuscation in here, using while loops that just do some tough calculation here that's gonna set it to true, and this would basically just enable to run this code, right? But when the application look at this, is like analysis software looking at this, it might be just like weird random obfuscation. So notice they're using this function a lot, right? So, and it's basically a hex of some type of hex code, some key here. So they do some decryption, right? So let's see a function. Okay, so cheesy string length and go, so binary to strings. Okay, because we have a hex value here, so convert it, then loop through every integer, and do short, right? Just so they do the mid strings of this with this is length, so form a, so basically is ASW is get the strings of this, then they do the sorted. So the function from here is just shorten, right? Shorten with this key right here. So let's go in here So how can we use CyberChef in here? I don't typically use CyberChef, but let's see. I need to improve this later on. Have a better window environment just to taking screen, right, and to make it smoother in analyzing this. Okay, so what we have here is let's get something bigger than that. So strings, remove this, so it's going to be from hex, right? Then we do a sort. Let's see if it works. And the sort is this key, which is UTF-8 kernel, right? So yeah, so in here, what we can do is we can write a script to parse out all of this strings, right? So searching for this, getting these things, getting this out, and extract out the and do this type of encryption. So do convert hex to this, right? And sort out. So yeah, let's do another one. Yeah, these Congo. Okay, so notice it's interesting that so one of the things, there's a little bit pain, which is good that they do this, is they're using random key, right, to make our life a little bit harder. So so let's see, let's try this. Let's do new. So we're gonna write a little Python script. Sys, okay. So function is decrypt crypto, no, strings key is equal to, so it's gonna be how to, I don't know if you can do hex in here. Like, right. So we can test this out real quick. So if we have a strings of this, can we do hex? So int 64. Right. How to convert hex string to bytes. I think it's there's a 2 bytes function from hex. Okay. Okay, that are strings. So let's disable this. 6 blah blah blah. Okay, so from hex, so in here is gonna be bytes. From hex, we want to be from 1 2, right? So it's gonna be 2, the rest convert it into buffer data, right? Then S is gonna be to this, I is gonna be 0, so y I is less than length data. We do S equal to S plus char or data I. So we want to convert it into an integer, then sort it with org key I sort length key. Right, then oops, then I equal to I plus 1 and return S. Let's see if that work. So do print decrypt okay. Where's I want to save this. Save as George decrypt. Okay. Let's see this malware 519 Python George decrypt. Missing key. What am I did I do? Oh, unexpected. Did I need 2 of this. Or expect but int found. Oh, because this is bytes already, so we don't need this. Because in Python 3 is bytes is integer. So, okay, so we got it correctly from our decryption here. So yeah. So then the next step is to loop through this and do. So one way, let's do quickly, is we can searching for all of this and extract it out. So what we can do is finding data equal to open sys org read I is equal to data dot find. Then we put this in here. Y I is less not equal to -1, right? So I would be, so we let's our function, when we first searching for this, we found this, right, the start of this. So I2 is equal to data.find. We want to find this first one at I plus 1. So I2 is equal to data.find this at I2 plus 1. So this would get us to finding the index of this one and this one. So the key is to get the substrings of this. So that would be encrypted data is equal to data equal to I2 and I3. So let's think that is, then let's break this here, and I4 would be data.find, so it would be pretty much similar to this right here. Data 4, data 3, and 4 and 5, right? Then would be print. Let's just do data of I2, I3. See how much that is, and print data I4, I5. So this, in hope that this should give us this buffer of data and this buffer of data. So let's take a look real quick. Let's do print charge. Oh, forgot the. I'm just gonna hard code it. Might be easier. So it's gonna be charge.a3, right? So we have this right here, but they got the extra character, so we need to do I2 plus 1. That means, oops, wrong one. This one plus 1 and I4 plus 1. Okay, so do we get it right? I3 equal to this and this one, right? Then we would call the decrypted data is equal to decrypt C data equal to this, and key is equal to this, and it will be encrypted data key, right? Then we would want to print it decrypted data. So x86. Okay, so we got it right. So the next step is to find the I is equal to data dot find this guy, and it will be I5 plus 1. Right, so we at this the last index is this, so we want to searching for this guy here. So let's run it real quick and see. Oh, we gotta remove the break. So now it's gonna be keep decrypting, searching, and until it's find can't find anymore. Okay. So, okay. Let's redirect this to decrypted.txt. And let's open up decrypted.txt. Might be, it would be easier. So basically, the goal is just to see what type of, if there's anything stand out in here, right? We've seen they do some recon getting the drive, get serial, but this doesn't mean much. So I think this might be just fake code, right? Code that they running that doesn't do anything. Windows J. Okay, this is interesting. Might have to search this in a bit. Catholic equation, or like, what is the objective of this? Is there a message to this or not? Curious if this is a known packer, known malware or not. Nothing stand out, so maybe finding another strings and we can show it. Typical researcher way, unless then instruction negotiation. Okay, very odd that they put this type of message on the in here. Yeah, window exists. This shouldn't get any correct code. It doesn't mean much when they execute it. So what is the intention? It just miss the direction, forced to basically pay attention to something that doesn't mean anything. Potentially, yeah. So they do allocs. Yeah, a lot of data, a lot of strings here that doesn't make a lot of sense. Get position, like get position sign again according. That's just a random junk. I'm curious how this script, right? Auto script respond to this type of command, right? Does it trigger an alert, or it just ignore it? Proper wall syntax nibble. Yeah, very interesting encryption, obfuscation, or junk code in here. So very interesting. So I'm looking, maybe I should just VBox. Should maybe just searching to see if there's any HTTP IP address in here that they calling out to. So known DLL right here. So serial user. nothing stand out. Just a lot of junks. So yeah, just a lot of junks. That's one thing I noticed is when analyzing like AutoIt script, it's a pain. This lost code right here. The obfuscation, the amount of code in it is just making life a little bit tougher. Just when we analyze this, reverse engineering it. Maybe I should just do HTTP. Nothing. Okay. So if we can't really find much from here, then that means that the code, the intention is somewhere else, right? It's not. This is just a type of like information. Likely it's gonna be misinformation that trick us into spending more time in this, while the malware is doing something else at later on time. So because yeah, it's heavily obfuscated. Leave copy trouble notice. It's so random. So if we don't find anything, then we would have to look at the original code and go through it and identify if there's any what the malware does, from the. Okay, so now we got something. The tappy and attend PD agent right here. Get drive. Potentially, there's another layer of like the payload is encrypted, right? And it doesn't use the standard encryption. So potentially that's the case as well. Okay. Serious? Okay. So this is interesting. So I should have done this earlier. As we scroll through this, there's a huge chunk of code here that is hex, right? I don't know what it is, but it's a lost payload. Look how, yeah. So what is this? All right. So let's copy it out. So it's hex. This is first time seeing this. So let's copy it, open up a new file. Gonna replace all of this replace it. Replace the end of this with end of it, and see if we can dump this into Shelf and see if we decrypt something. So let's disable this. So unhex it doesn't give us anything. So there might be something else, right? So what does it do with it? With this? So what we want to do is copy, find this, decrypt it, and okay, so as seen here, the converted, what is this function? Right, if binary, we want this guy. So convert this to binary. Curious if this is a shellcode. Let's do the decryption of this first. What is this? Yeah, copyright. So convert this, decrypt this, got this, then they convert this to binary, then they call this. The license is this. Then they call Virginia extracts, and they call, let's copy this over. I can create another notes here. Binary length of Virginia extracts, set the data this, then they do some type of decryption here. Okay. So they do the show. No. do. So they set the data here. Get pointer. Potentially this is shellcode. I doubt it. Maybe that's all it is. It's just a shellcode. Let's convert this. Copy this. Let me disable this. So this, oops. Delete this. Just form hex. Then save it. Charge payload exe.bin. And we're gonna save it in here. For right now, yeah, maybe the next time we take a look, because yeah, this is fairly long sample to analyze. Just a quick one is, let's do the check to see on VirusTotal if there's any information about the sample. So on VirusTotal, let's see. So it's a known, analyzed it 18 hours ago. And it download a variety different contact, download different data payload here. So let's just copy this for right now, save it so we can process, analyze it. In case it fail or get removed. So this one get removed already in here. Let's go back to here, see if, so they're using compromising this WordPress app, and they put the storing the payload in here. So yeah, so next time we're gonna resume this and maybe go through this a little bit more and analyze it, or potentially just skip and just start analyzing this. So likely this is basically the C2 right here, where the script download, right? So, but I think this is the shell code that containing the payload to performing the download. So maybe we spend more time in this to understand it a little bit further. So, but it is really interesting malware using variety different techniques, from basic, encoded or encrypt the auto script, then in the auto script contain a lot of junk code in here and encryption that causing the more time in reverse engineering it. So really interesting payload. So next time we resume this. Thanks.